In this lecture, we'll talk about compilation process. The Solidity source code is passed to the Solidity compiler, and the compiler returns the Ethereum virtual machine bytecode that is deployed on the Ethereum blockchain and the contract abstract binary interface, or ABI. We have something like this. We have a smart contract source file, a .sol file, and then the Solidity compiler takes this file and generates two information: the abstract binary interface and the contract bytecode. Then the contract bytecode will be deployed on the Ethereum blockchain. The contract binary interface will be used by anyone that wants to interact with this contract. There are many Solidity compilers available: the Remix browser-based compiler, the command line Solc compiler, and so on. By the way, the Solc compiler must be installed, and on Ubuntu it is very simple. We have also a Solc.js compiler, which is a JavaScript-based Solidity compiler and can be installed via Node.js with npm install Solc. ABI is a list of contracts, function, arguments and state variables, and it's in JSON format. ABI is known at compile time. The ABI is generated from source code through compilation. If we don't have the source code, we can't generate the contract ABI. Then only from the bytecode using reverse engineering, and this is not always very simple. Anyone that wants to interact with the contract must have access to the contract ABI. ABI is basically how you call functions in a contract and get data back. You must also know that contract bytecode is public. It is saved on the Ethereum blockchain and can't be encrypted because it must be run by every Ethereum node. Then we have the opcodes. This term comes from operation codes. These codes are the human readable instructions of the program. It can be easily obtained from bytecode. There are also tools like Porosity that can reverse engineer the bytecode to source code. Anyway, the contract source code doesn't have to be public, but many contracts publish their source code in order to build trust. Okay, let's go to Remix browser. I have a simple contract named message, and my contract has one state variable named lines and two functions. One setter function that modifies that state variable and one getter function that returns my state variable. Let's compile the contract. Anyway, if I click here on auto compile, Solidity will compile my contract as I type. So if I type here something, it tries to compile the contract. Of course, there is an error. So the contract is already compiled. And here at details, if I click on details, I will find many information. For example, I'll find information about the bytecode. This is the bytecode, this information. I'll copy the contract bytecode into another editor to see it clearer. So, this is the contract bytecode. If I deploy the contract, this is what will be deployed on the Ethereum blockchain. The contract bytecode is represented in hexadecimal. The opcodes are these values from here. So as I said before, opcodes are the human readable instructions of the program. If I see something like this, I don't understand. No one can understand. This is only for the Ethereum virtual machine. It's low-level data, but I can translate this information to operation codes. And the translation is this. I'll copy paste these opcodes into that editor. These are my contract opcodes. So push 1, 0x80, push 1, 0x40, MS store, call value, and so on. Anyway, from the bytecode, it is very easily to obtain the opcodes. I can go, for example, to etherscan.io And there is a tool, a bytecode to opcode disassembler, that translates bytecode to opcodes. I'll copy paste the contract bytecode to this disassembler. So copy and paste here. After 0x, this indicates that the representation is in hexadecimal. And now I press on decode. As you can see, the translation of this bytecode to opcodes is this. Of course, it's the same as in Remix IDE. If you want to see all available opcodes, it is very simple. So EVM opcodes. And the first link takes us to GitHub, and here we can see Ethereum virtual machine opcodes and instruction reference. So these are the opcodes. So stop, add, mul, sub, div, mod, and so on. Let's return to Remix IDE. Now we see the Web3 deploy section. This is how the contract will be deployed using Web3. So simply it will deploy the value from data field using this recommended value of gas. We've talked about gas in another section. Very important is the contract ABI. This is the contract ABI. Let's copy the information, and here in this editor I'll paste the information. Okay, now we see it clearer. So what does the ABI mean? It represents all functions and variables the contract has. This is the first element, the second element, and the third element. Let's take it one by one. So this element represents a function. Its name is getLines. It outputs or it returns an uint 256, and there is no argument. Yeah, this is in fact this function, the getLine function. Then we have the setLine function. So back to my editor, we can see the representation of my setLines function, and then we have information about my state variable, about the lines variable. So if someone has this information, the ABI information, that person or that contract, it could be an application, could interact with my contract. It knows what functions are available and how can those functions be called. Without the ABI, there is no possibility to interact with the contract.